All right, welcome everybody. How's everybody feeling? What? Well, really excited tonight to talk to you. We have great speakers about Node.js. At our last survey, every year we do a sort of annual survey in December, and we ask people what they want to hear. And one of the big, requests was more about Node.js, and so here we are. So we have some of the experts in the house. Really excited. Everybody on the live stream, welcome. We have a couple hundred people joining us on the live stream as well, which is great. And I've got a packed room here in San Francisco. So before we kick it off, just a couple of quick housekeeping items. We recently crossed the 10,000 member border. We're actually almost, yep. Actually already pretty close to 11,000, so it just keeps going, right? Incredible. So all of our talks are recorded. Some of them are, or actually lately a lot of them have been live streamed. But we record all of our talks, and the combined body of work for the last 4.5 years, we now have close to 1.2 million views on YouTube already. So it's pretty exciting, and you can find those on bit.ly SF-HTML5 videos. So tonight, if you are active on social media, Twitter, Google+, and so on, Node.js and SF-HTML5, we have a couple of great prizes. And so some of the most creative ones we will award with some swag. All right, maybe a quick shout out for DJ Rocky Lubbers. Great, so available for your parties. All right, so I wanted to thank a couple of the sponsors. We have a couple of them here that will say a few words. It's really exciting to see so much support from the sponsors that keep all these events going for free. Of course, Google for the venue and the great food and all of the great stuff here tonight. So maybe a round of applause for Google. And so at Google, we kind of put on a lot of sponsorship behind these kind of events, these community events, because we really want to do that as part of the developer relations efforts here. And we really try to get a lot of great stuff, put it on in a recording, and make it available at scale worldwide. And another thing we're doing, apart from these videos that you can find on the Google Developers YouTube channel, we're also building a lot of great courses on Udacity specifically. So we teamed up with Udacity to create some MOOCs, massive online open courses. And we've talked about some of those in the past, and we recently launched a really good one about web performance optimization with a former speaker, Ilya Grigorik, who is going to tell you about the critical rendering path first, something that there's not a lot of information about at all. And then actually find ways on how you can optimize your sites, keeping that information in mind. So definitely check it out. It's a little different from the other classes we've launched in that it's much shorter. It's something you can literally do. Well, I did it in an evening, a long evening, but you can easily do it in a weekend. So it's something you can mix and match. We have some longer form courses, for example, mobile web development with Chris Wilson, and the HTML5 game development with Colt and myself. You can take those, and that will take you several weeks. This one is a quick one, and will really give you some great tips. All right, so I want to thank a couple of the other sponsors, and some of them are represented here. The first one is founding sponsor Kazing.
G'day, my name's Robin Zimmerman from Kazing, and I run product management there. And Kazing was one of the original founders of this meetup, which, as you just heard, is very big. I think it's actually one of the biggest of all the meetups entirely, isn't it? And I think it's actually the biggest web one altogether. So it's a huge group. Yeah. All right. So at Kazing, we were one of the original contributors to the WebSocket specification, and key parts of the spec today come from the original contributions that Kazing made. And we were the first ones to have a production WebSocket server out in the market. Why am I telling you this? Because I'm hoping to lure some engineers to Kazing. So we have a crack engineering team with some very smart people. So if you are a crack engineer and you like working with some smart people, then please come and talk to me. Talk to myself or to Vanessa. And finally, just one quick plug. We are giving training next month from Richard Clark, who's presented here before. And you can find the details of that. You can either ask me or you can find it on the website for this meetup, sfhtml5.org. Thank you.
Thanks, Rob. All right, a couple of other sponsors. I want to thank Intel, Adobe, Modern IE, ClearSlide, and HTML5 DevCon. So it's happening again. It's a twice a year HTML5 developer conference, the biggest HTML5 conference right here. This time in October. It's going to be on October 20 and 21st. There's also some training days around that, and it's going to be at Moscone. I think the last time it was there, it was about 3,000 people were there. It was a great event and very reasonably priced. I forget the exact price, but this is a very affordable conference. All right, we have a new sponsor tonight. We are welcoming Twitter into the fold, and
Hi, my name's John. I'm with Twitter Developer Relations. Our goal is to get out here and interact with you guys, learn what you guys play with and what you guys like to develop in, and ultimately help you guys integrate Twitter into your applications and products, whether that be Twitter cards, the REST API, the Stream API. If you happen to be mobile developers, you can monetize with Mopub, one of our products. You can also implement Crashlytics, which lets you do beta testing and crash reporting in your mobile apps. And yeah, thanks for having us. And if you need any help integrating any of that stuff, stop by our booth. We have a Node.js demo running at our booth. Come check that out. It's all hooked into WebGL and Angular. So yeah, thank you.
thanks, Jonathan. All right, a couple of other sponsors. Bounty Source, we're happy to have them. Lude, Leap Motion, we have Edwin here.
Hello, everyone. I'm Edwin Abarca with Leap Motion Developer Programs. We are a small USB peripheral that you can use to interact in 3D space with your programs. If you want to check out something that we just released yesterday, we have our VR demo set up at our table. We're between PubNub and Twitter. Also, as part of the raffle today, we're giving away 2 Leap Motion controllers. So make sure you keep a hold of your tickets. If anybody is a Leap Motion developer, go to developer.leapmotion.com and check out the new SDK, which includes our VR packages. Thank you.
Thank you. Great. PubNub, Tomomi, in a new T-shirt.
Good evening. It's a Friday night before the Labor Day weekend. What are you guys doing here? It's pretty awesome to see here. Actually, it's cool. So my name is Tomomi, and I think some of you already know me because I'm a regular at this meetup, and I'm actually the earliest members. Now we have 10,000, what? Oh, almost 11,000 members, right? I'm the earliest one. But yeah, but I guess you never seen me in this PubNub T-shirt before. So I just joined this company because PubNub does such a cool stuff. And also, I know I look better in red. Yeah, right? Okay, enough about myself. So what do we do at PubNub? So we offer a data streaming network. And we offer a whole bunch of SDKs. You know, we support a lot of languages like JavaScript, of course, and JavaScript, Node.js, Ruby, Golang, and Java, such. And for mobile platform like iOS, Android, and PhoneGap too. And if we want to do some cool stuff, you know, cool project with IoT, we have our Arduino and Raspberry Pi as well. So yeah, and well, for JavaScript, you know, I bet that many of you here are most likely to be using JavaScript APIs. That's what I do use personally too. And not because I'm in Google today, but we actually do have PubNub element with Polymer. And we also have, yeah, take care of the AngularJS as well. So you can install using NPM install PubNub. Or you can use Bower. Bower install PubNub-Polymer or -Angular, some cool stuff. And yeah, so, you know, as a JavaScript developer, when you're talking about like fetching the JSON data, you know, I bet you guys, well, first thing is think about using XHR, right? So for the like Ajax call, it's like a single request response call. So you request and get response from the server, and the connection get closed. So if you want to get like JSON, you know, streaming data continuously, let's say, you know, like your data, the data is updated in the server. How you get notified in your client? So you might think about like data polling using, well, maybe set intervals. But, well, you can do that, but still, it's a lot to take care of for your browsers. So why don't just, take advantage of what we have? So you can sign up free at pubnub.com. And even better, we have this evangelist program. If you are open source programmer, open source developer, or like indie developer, you can get this free forever account. It's I had to read this, pubnub.com/free-evangelism-program. Or we can just talk to us at the booth over there. All right, thanks, peace.
Great. Thank you, Tomomi. All right, I want to also thank Matrix and Moboom.
Hi, my name is Chris, and at Moboom, we've built a platform and are now building an ecosystem that will help designers and developers build future-proof websites. We believe the decisions you guys are making now about technology should not have to impact you negatively 3 to 5 years from now. And we know that with languages as they're ever evolving and changing. The decisions that you're making now can really impact your career and your business 3 to 5 years from now. It could become potentially obsolete. So we're in the business of potentially providing you guys with a way to future-proof your website. So anybody here tonight that wants to check out our platform can sign up for our platform for free for a year and check us out at our booth. Thanks.
Thank you. All right, and our final sponsor to thank is Sony. Okay, we've got some great prizes tonight. We have a whole table full of wine, books, Leap Motion controllers, a Chromebook to raffle off as well, as per usual. So, so hang on to your tickets, and we will do that. So a quick little update on or overview of the schedule tonight. We will take we have 2 talks. D. Shaw and Trevor Norris, and then we have about a half-hour break around 7:30. Come back in here. We may have 1 or 2 lightning talks, and then 2 more talks until about 9. We take a short, quick break over there, and then we have the panel of speakers that are going to answer all your questions. We'll set up a mic in the middle, and then the raffle. So exciting stuff. One final thing. Last year, I don't know how many of you were here for the Perf Matters event. Anyone here? All right. All right. Okay. So this time we're going to try to top last year's event, which was not easy. So it's going to be here. We're going to have a great time. It's going to be Perf like a pirate. Actually, we have sort of a little bit more general performance event planned. So we have actually 2 talks that are mobile and /Android related, and then 2 talks specifically for web performance. So it's a little bit more broad. 4 great speakers. I mean, some of them have been here before. So definitely sign up for that because that's going to sell out completely. All right. And with that, I want to hand it over to D. Shaw, who is here as our first speaker. Is going to tell you a little bit of the high-level parts of Node.js and where we are now. Again, all of you, there was a lot of demand for Node.js talks, and so we tried to put some of the best together here tonight, and hope you enjoy it. Disha, come on up.
How's everybody doing? So, before we kick off into my talk, and my janky graphics. Is this on? Can you hear me? Great. I'm going to kind of lay out where we're going this evening. So we have a very interesting kind of eclectic mix for you, and that very much represents the world of Node. We're in the enterprise, in embedded devices, in mobile, all over the place. So I'm going to share some of my experience, some of what I've been helping grow in the Node community, and then after me we'll have Trevor Norris, Node core contributor, and we're going to go really deep into some core stuff that is sort of very low level, and then we're going to come up from there. and Eric Toth of PayPal is going to share some of the experience of the transformation that's taken place at PayPal, and really the pervasive Node that is driving PayPal now. So it's really exciting. And we're going to close out with Guillermo Rausch, the creator of Socket.io, and WebSockets, and sort of connecting it back to Kazing. This meetup is really special to me because it connects back to the very earliest parts of my career that were with WebSockets. I unfortunately made the choice to go not with Java, but over to this Node thing. It was WebSockets and Socket.io that really kickstarted that part of my career. So we're going to bring it home with Guillermo and WebSockets and Socket.io. Socket.io got to 1.0 before Node got to 1.0. So it's really exciting and an integral part of Node's growth. So, that's the evening. Let me dive into Node.js and what's going on. So I'm D. Shaw. I am the co-founder of a company called NodeSource. We do Node for the enterprise. We help large companies run Node effectively. Before that, I co-founded a consortium, a group of individuals that came together early on in Node's history to provide professional services for Node, the Node firm. I've worked at a bunch of startups with Node at Storify, Spreecast, Voxer, ClassDojo. If you enjoy hearing me and ah and all that stuff, you can listen in your eardrums to me on my podcast called Node Up. I run a couple events around bots and Arduino stuff. NodeBots SF. Nebrius is here. I don't know if Miles is also here. Great group of people where we come together, and it's really kind of the antithesis of this event. This event is special person dropping knowledge on other people. The NodeBots, I compare it to getting together and basically building Legos with friends. Closest as I can get to that. It's just hacking, sharing, and hanging out. So NodeBots Day and NodeBots SF. It's a very special, kind of very different meetup that I created. So let's dive in and see why Node has been so important, and why Node is relevant, and why Node will continue to be relevant for, let's say, 10 years. I'm not going to say that Node is going to be relevant for forever, but there's a incredibly positive story for Node in the next 10 years. And the foundation, the anchor of that is because Node is a platform for running JavaScript on the server. It has increasingly been a part of how we build applications. We with the dawn of HTML5, we really now have the tools to build what we want with JavaScript on the web, and that is driving ever more greater importance of JavaScript and the need for dynamic and effective backends. On top of that, we're building services that need to be responsive. And I'm stealing the responsive word from responsive design to illustrate a pattern that we've seen in the back end, where perhaps you have a API endpoint that returns a lot of data. Awesome for your web app. Really horrible for your mobile application. Mobile application, you need something that's tailored for that. It's been an area where Node has really excelled. You can craft and deliver content that is precisely targeted to the needs of the device. And Node is an incredible lightweight engine to drive that. The Internet of Things has been another factor increasing the relevance of Node. The democratization of programming, really, with JavaScript, and it has been augmented by the democratization of hardware with Arduinos and Raspberry Pis. So connecting that to our services and our infrastructure has been really compelling. And beyond that, there's new opportunities inside devices, inside of switches, inside of the devices that are powering the internet that is ever more increasingly important. So we have this beautiful language, beautiful with warts, language, JavaScript. But the fantastic thing about JavaScript that it's incredibly approachable and everywhere, and it powers all of these platforms. When I went through the transition from being a JavaScript developer, middle-tier developer, doing the back-end services in Java and the front-end services in JavaScript, I was blown away once I moved to JavaScript on the server side, how fast I was moving. It was absolutely incredible. So this rapid cycle time and what I like to call the time from ideation to realization really becomes much smaller when you're working with a dynamic language, if you want to get language geeky. But JavaScript is a fantastic expression of that. And then if you're looking at JavaScript and its relevance, this is being reinforced and becoming a competency that business leaders are looking for and hiring around. And the fact that now we have front end pervasive, tooling pervasive, back end pervasive, it's growing and snowballing into a really relevant career path. So as we explore Node, let's go and look at what it took to get here, because it was not all roses for the entire history. Back in 2009, we had the original presentation of Ryan Dahl's hacks. 2010. When I started adopting Node and then left my job and then basically came out to San Francisco and abandoned everything to come work on Node. I'm not allowed to curse. Things were really broken. The ecosystem was really fragmented. We didn't have a package manager. We had Kiwi, which was kind of janky from TJ Holloway-Chook, and Isaac came along with NPM. Thankfully, we kind of came together and decided to have one mechanism for delivering packages. Your promise lovers, we got rid of promises then. So we explored a lot of patterns, broke a lot of things, and really brought together a fantastic platform. Fast forward a year, and 2011, with the .6 release, we introduced Windows, and we don't have laptops out. But there's a sea of silver in here, I'm sure, if you pull your laptops out, and the systems that are not Macs are probably Linux machines. But if you go outside of the West Coast, you go outside the Bay Area, Windows still dominates the world. And if it weren't for Microsoft's investment in Node, I honestly don't think that the platform would be where it is today. So I am really grateful for that evolution in Node. Even though I spend very little time in the Windows ecosystem for Node and its success, if we didn't have that cross-platform ability, and if you look at other platforms that have chosen to sort of eschew and ignore Windows, they haven't evolved as much. So this is a pivotal point in Node's growth. 2012, it was all about the real time. Socket.io is booming. Everyone's working with Node, building great things. In 2012, spent a lot of time with Steven out of Publo. Not Node, but great architecture. Fantastic. Real time has been pivotal to Node's growth. The low latency I/O is just a fantastic fit for that. Then in 2013, we introduced the enterprise. Walmart comes along, and they have their Black Friday event running all their mobile, I think it's a large portion of their mobile traffic on, through Node, and having it be a rock solid Black Friday. That really encouraged many others to come along behind it. And so you had Walmart and PayPal really paving the road for large-scale Node. And 2014 is it's really become pervasive, and one of the default choices where new development, new platforms are growing, and the productivity that is being done in Node is letting these organizations choose that, and all of the foundation of why we're building JavaScript applications has driven the growth of Node. So, as we're looking at building applications, let's see what has led to Node's success in these environments. If you look at large systems that have evolved over the years, and you look at, I'm going to pick on Java a little bit. You look at Java apps, it is typically one big monolithic application. And I know, dyed-in-the-wool, Java developers will say that you can go POJOs, you can go, simple, minimalist Java services. Awesome. Engineering good practices are, in a way, universal, and you can apply them in, most every language. But typically, what you see in Java applications, Ruby applications, PHP applications are large monolithic applications, and this tends to slow everybody down. And over time, having all of that code having to go through this bottleneck, these applications were incredibly behind schedule, and in fact, 6 months to 2 years behind schedule with some of these other platforms. The reality is that shipping code wins, and the time to execution, the time to realizing that that engineering effort is greatly reduced in building out an application that I'll step away from Node, latch on to the principles of engineering. So a smaller thing, you can iterate on it faster, period, right? Node tends to encourage that. So one of the biggest impact in the last year or so areas of Node's growth has been the front end, back end. It's a really odd slice of the application architecture, but these rich client teams that have been building out these fantastic dynamic JavaScript experiences needed something more. the monoliths that were driving the delivery of these applications were just too slow. You need, as a front-end engineer, to rapidly iterate on the customer experience to respond to their needs. So the introduction of front-end, back-end, it's a back-end for your front-end services. So templating and CSS and all that stuff is moved out of the monolith, the big application, into this lightweight, dynamic node layer. It's not incredibly sexy code there. It's very utilitarian, but it's extraordinarily functional and absolutely allows these user interface engineers, these front end teams, to operate in a whole new way. From my experience as a developer that did back-end services and front-end, the ability to also think in JavaScript is insanely liberating. So let's look at the impact of the front-end, back-end. These engineers that are crafting the user experience are the front line of what everyone experiences. So it's extremely important that that area of the code base be dynamic. Your back-end services that talk to a database through data schema probably doesn't evolve weekly, but your front end may evolve moment to moment. There's a baseball game. There's an earthquake in Napa. You need to address that, what's changing, and deliver an experience that is appropriate. So Node is empowering these front-end teams by allowing us to really put in front of them the tools that they need to deliver the experience that they want to. So we're able to pull away from some of these weird architectures that are delivering HTML, HTML5, whatever, HTML, CSS, and the JavaScript. If you've gone to Java land or C++ land and had a C++ or Java abstraction for CSS that you have to it's a nightmare scenario. You can't take your expertise in all of these technologies and apply it to it's so incredibly separate there. So we go in and reduce that crazy abstraction, get rid of that, allow front-end engineers to operate within their specialization and be able to focus on what they're doing. They don't have to go through a middleman, essentially, to produce the experience. You can rely on the knowledge and your expertise that you've built up over your career. So the biggest thing for me in going through my transition from having to do back-end services in Node and something other than Node, and delivering a front-end experience is not having to context switch. I would go build UI components and then on a separate day have to go and sort of go into Java mode, database, ORM in Java, Hibernate, all that stuff. It was really, really mentally challenging to go back and forth. Enjoyed programming in both, but not having that context switch. A lot of times we're crafting API elements that we're delivering new experiences to user. You can rapidly iterate on the back end, rapidly iterate on the front end. and really pull together a fantastic experience, without that cognitive load that's involved in going back and forth between platforms. So, what are the ways that we can really embrace Node, incorporate Node into our ecosystem? How do we accomplish this front end, back end? One of the biggest things that I've seen in the success of front end, back end is the use of an API, having an effective abstraction layer for your data. I've thrown out the concept that databases must die. I got a lot of backlash for that, but essentially what I mean there is that you should be talking to an API. You should not be exposing, and this is, again, this is not Node specific, this is engineering in general. You should be exposing to other tiers in your architecture an API, and then if it's your responsibility in the various tiers of things to talk to a database, that's fine. There you have database connections. But if you're doing template rendering and rendering JavaScript files and CSS rendering, you should probably focus on just that. Separate out those concerns, focus on that, create a lightweight API layer that talks to your data services, aggregates them, and really focus the areas. You'll design better, smaller, more effective applications that way. So that ends up basically looking like proxies all the way down. These smaller apps, it can feel a little bit weird, but there are once you break things out into these API layers that are talking, you're essentially handing off the data through these various tiers. So if you're looking at an application that's going through all these hops, that is a very effective pattern in Node. And if you need to take a data point away for oh my God, latency bad, network bad, in an internal network with Node, you're looking at about 6 milliseconds of added latency going through Node. So Node is very, very efficient at doing streaming I/O. That allows you to have very fluent interfaces for communicating with your data. To do this, we're using a dynamic language, rolling this out into any scale. Do yourself a favor. Don't set aside testing. Test early, test often. And to make that effective, automate it. Automate your testing. Have that baked into your ecosystem. Automate the process of shipping code. I've always been a fan of continuous integration and continuous delivery, not so much for the fanciness of we're shipping code every XYZ times a day. The reason why I love continuous integration, continuous delivery is it forces you to do this. If your code is going out all the time and you don't have effective tests in place, someone's going to be unhappy. And so, they're great patterns that allow you to work effectively. So Node is really growing and becoming an essential part of how we build things, from servers to build tools throughout our ecosystem because of JavaScript. And I'm grateful for the ability to write JavaScript everywhere. It's fantastic. Thank you very much. So I'm going to bring up Trevor Norris, and I guess as Trevor's getting set up, we'll have a larger Q&A panel later today. But if you want to ask any questions, happy to take one as Trevor recompiles his kernel. Linux user. Yes. Right. Sorry, I need to repeat the question. So the question is, there's 10 years out. What is out there? I think that would be driven by what web technologies expose to us. The web is, the driver for JavaScript, and one of the reasons why JavaScript got to this level. If we begin to see pluralities in the web, I'm at Google, so Dart. I don't think it's going to be Dart. But if the browsers can introduce a language that that begins to become as pervasive as JavaScript, I would look to that. We actually on NodeUp we have a show scheduled for next week on Node versus Go. Again, I don't think Go is a fantastic language. It really does a beautiful job at being a better C. But it was designed to be a systems language. Node was designed to be an applications language. Node's extremely, extremely effective at being an application language. I'm okay doing systemsy things. At NodeSource, we actually end up recommending that a lot of companies do not use Node for all their things. They're systems tools that are really good and really effective at doing what they do. And build your applications. Use JavaScript and that velocity to build your applications. But it is not a universal panacea. It's a fantastic tool. But in every large installation of code that I've seen, there's an incredible plurality of languages that continue to exist. And even though JavaScript has taken over a lot of the new growth in many of these instances, the presence of Java and presence of C++ at your larger code bases are still there. So what comes in after JavaScript, in my mind, whatever the web drives in, and very 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 possibly could still be JavaScript. Yes. Sorry, sure.
You mentioned about contracts and APIs. Considering RESTful API, what would you say about some of the communication at edge, is it like RAML or API blueprint?
So the specifics of what are the effective tools for REST APIs with JavaScript, right? So the contract patterns there. I think actually Eric Toth can probably speak better to this. I tend to be a little bit lower level than that, but I believe they have been exploring RUM. The API contracts, what are the effective patterns? That is an area that the Java world has really excelled at, and that the JavaScript world has done less of a good job at addressing and tackling as a fundamental part of what's going on. So schemas and what is the, I know you guys are using for your REST APIs? Swagger. Swagger seems to be increasingly popular. I do think there's I always get a nice cringe when I mention waddles. WSDL waddles. WSDL was really influential in introducing us to service-oriented architectures. Waddle, is XML to describe JSON, and that sucked. So it's not a great pattern, and if you ask any JavaScript developer about XML, they'll kind of back away. But I do think there's a lot of room for improvement there, and if you look at API definition discovery and a lot of the things that came out of the SOAP era, the patterns for that have not really concretized in JavaScript, even though the use of it is probably even greater. So we'll be back. We'll have a panel and probably some discussion. Hand it over to Trevor Norris. I'm going to steal my water.
Thank you.
Thank you.
All right, quick introduction. My name is Trevor Norris. I now work at the Node Source. Previously worked in Mozilla, and then before that worked with companies. I did a lot of front end. I worked on doing a lot of enterprise level front end. My first language was JavaScript. My only language was JavaScript for about 6 years. Honestly, until I became a Node core maintainer, at which time I was forced to learn C++, and ever since then, I've just started moving down the stack. Currently, I'm learning C and aspiring to become one of the libuv maintainers as well. So I'm just going completely the opposite direction, which is really odd. But I do have to say that coming from client side and going to server side, and then going all the way down to like systems level development, has given me a really, I'd say, unique insight into how things work. Tonight, my talk is going to be about dealing with a lot of requests. Like, let's just get kicking. So I did a very unscientific analysis of just going to a bunch. I just went to what is Alexis and just went to like the top 100 or something websites and just viewed how many calls were required just to load the homepage. And the majority of them were 50 or more requests just for the homepage. I remember a time where this would have been insane or ridiculous and people would have never allowed for it. But it's very common now. And it's a new way of dealing with things. It's a new way of looking about how we write our applications. Now, as it says here, many of those are static content, images, JavaScript, and CSS. I'll get to why I air quoted those later. But a lot of that is static, but also there's a good amount of dynamically generated content. And that is where Node is sitting today, at that level where your dynamically generated content is being processed and delivered through Node, whether it's doing a backend call and delivering JSON down to the client so that the client can render the DOM on the fly, or whether templates are being generated on the server and being delivered to the client. So here are several of the most popular pages. And that number is the number of requests just to load the homepage. And then I broke it up into number of HTML, JavaScript, and CSS files specifically for each of those. And I'll get in later why those three are important. The rest of them are images and whatnot. But as you can see, that's borderline insane. I mean, I'm sorry, over 250 individual requests just to visit the homepage, that's a lot. I have a really fast connection, but I mean, fortunately, like Amazon.com has a mobile site, so they don't do that, but a lot of people don't. And so when you're doing crap like this, and then you want mobile users to try and use your website, you're crap out of luck. That's just not gonna work. So common uses for Node I've seen today are for template generation, REST APIs, static content concatenation, and metrics reporting. The reason I place the template generation and the REST APIs separately instead of together is, excuse me, is because the template generation will make your application CPU bound, where REST APIs generally make calls out to other resources. And so your application then becomes bound by whatever external resource you're calling to. A lot of times, it will make a call out to a resource, grab some JSON. Like this is usually the case where you're sending JSON down to the client, where the client will dynamically render the DOM. But template generation will make your application completely CPU bound, which is, to be honest, I'd say the oddball case for Node, because Node is touted as being very friendly to I/O. But template generation is an important thing. Its use, as I've seen it, has increased in popularity in generating templates to generate the actual HTML for the page. Static content concatenation, we'll get more into that later, and then metrics reporting. This one is interesting because, say, for example, you want to keep track of how well the ping back, if you want live metrics on how many people are visiting a specific page, right? So that means however many connections you have, you know that you will be getting that number of requests per 5 seconds or 10 seconds at minimum, just for the ping back, plus any additionals. I know there are some that keep a ridiculous number of metrics on everything that's going on the page, and it's constantly making requests back to the server, right? And this can put a lot of load on your servers. We'll get into part of the reason for this talk is to instruct how to get around these things. Now, a few common problems I'd like to point out are Node applications are becoming more CPU bound as more template generation is happening. So the number of requests expected are dropping. Excuse me. People delivering static content through Node, which is just crazy. Don't deliver static content through Node. You have CDNs, you have a huge number of other resources to deliver your truly static content. Don't use Node, right? Make sure it's filtered out. One very common one I see is when the browser hits the service and then it makes the request, but then straight up it makes a favicon request, right? Now the HTTP parser in Node is not cheap. We're going to improve that, but currently, as it was designed for backwards compatibility, we haven't been able to make as many improvements as we've liked, and it is not cheap. And so that one extra request, imagine every request automatically generating one more request, right? Just to have it be immediately dumped is just a waste of CPU, right? Make sure those things are filtered out. Now, external API calls being a bottleneck, well, then you know Node is doing its job. If Node is sitting there at 5%, maybe 10% CPU usage, but you see like thousands of connections on your application, then you know you're okay because you're waiting for some other service to return you information. And there's nothing you can do about that at the Node layer. And then another thing I see is people allowing connections to be received by a Node process until the process falters. What we should be doing is doing performance testing, keeping metrics on our production systems, and finding the sweet spot, right? Finding the arch of where that begins, like where it begins to decline, and don't allow it to exceed that, right? Shoot to maintain that as best as possible. So these bullet points will hit in more detail, so we'll just address them quickly. So don't immediately write small packets. Reduce the number of requests in total. As you saw, like there are a ridiculous number of requests. For the ones like images and whatnot, that's not such a big thing. Not a lot, in my mind, we can do about that. But as far as the numbers you saw for the JavaScript, CSS, and HTML, there is a solution for those that we can address. And then also, remember that Node doesn't gzip your content by default, right? So a lot of times, you're streaming out content, and you're forgetting that your render template is 50 to 100 kilobytes, but you totally didn't set your gzip encoding and actually gzip your data, right? Node doesn't do that automatically. So you need to remember to do that within your own applications. All right, so hitting the first bullet point, don't immediately write. I've seen some template modules, and honestly the more popular ones, default to what's called streaming mode, where every time a segment of template is generated, it calls response.write for that segment. But instead, what you should be doing is aggregating the results and sending them out all at once in a single request. This has two advantages. One is that it allows you to set the content length header. And that is important. As a general rule of thumb in Node, if you don't set the content length header, you will get approximately 50% fewer requests per second than if you are to set the content length, right? If you can set the content length, you will do much better in terms of performance. Now, some people might say, well, I want to get data out as quickly as possible. Truth be told, that's actually not the case. If you're streaming out lots of small requests, what's happening is you're incurring a syscall time, and you're incurring a, excuse me, you're incurring garbage collection time. Like, there are lots of small things that accumulate with lots of small writes. And hopefully, your template generation isn't lasting more than 10 milliseconds. If it takes you more than 10 milliseconds to do whatever synchronous operation you need to do, you need to rethink your design, because that's what Node, that's not something Node should be doing, in my honest opinion. And so waiting 10 milliseconds for sending out the beginning of the content with the end of the content should not be an issue. So now a note about O.12, which is we currently have a branch for. Right now, it's pretty much in feature freeze, and we are working on fixing bugs. Like, there are a few with, like, now that promises, native V8 promises are in, there are some bugs around that and other things that we're finishing up to make sure that it's usable and fully working and stable. But one feature that was added, which I believe is important, is that in O.10, every time you call socket.write, or just like response.write in terms of the HTTP module, that makes a syscall. But coming up with TCP is the ability to call the Quark API. And the Quark API uses what's called the write v syscall. And what happens is when you Quark, it will then halt, like, you can call write as many times as you want, but internally, it will aggregate all those, and then when you either call unquark or you end, like at the end of an HTTP call, you call, response.end, it will send all the data down and make one single syscall to the kernel and say, read all of these out as one giant buffer. The write syscall, you have to write out each individual buffer, but with this new API, it can treat many buffers as one. We've seen very high throughput increases in writing out small requests because of this new ability. And it will be enabled by default for the HTTP module in O.12. I need to clarify that and say by enable by default means when you start writing HTTP data, right, it automatically quarks at the beginning of the synchronous code. And then it will allow you to call response.write as many times as you want. And then at the end, it will automatically uncork it for you if you haven't called response.end, or if you have called response.end, it will be sent down. right? So in O.12, if you write out something immediately, it won't be sent out immediately. It will be sent out when your synchronous code execution is complete. Again, hopefully your synchronous code execution isn't taking more than 10 milliseconds. But yeah, that will be enabled by default on O.12 for the HTTP module. I believe it only works on Linux, but since the majority of servers we've seen run on Linux, we figured that would be a big gain. Now, there's an idea of a well-formatted request, and that is when you have an internal API, you have your own JavaScript libraries that you are programming, and it is making a call to the server. The format of the request should be well-formed. It should have a very specific format, right? Your REST APIs, requesting content, all of these things should have a very specific set of headers or a specific GET request. And with these, you can actually bypass the HTTP module entirely. We'll show some code here in a second. But what you can actually do is open up a TCP socket and then allow HTTP connections to be made to that TCP socket, manually extract the data you're expecting from that API call, and make the response as quick as possible. Say, for example, you're doing a RESTful API, and the only portion of the message you need to know is the GET request. But say, for whatever reason, there are a large number of cookies or something like there are a large number of headers that would require to be parsed, you can bypass that entire segment by doing that manually. Now, this is on the more advanced level. This is on the high performance level, but that's generally what I do. To be honest, I get a lot of people that come up to me and say, you know, our application is just fast enough. And we'll talk more about that later, but I don't, like, to me, there is no fast enough. I measure performance degradation in nanoseconds and clock cycles. I dump out the assembly code of the JavaScript that I create. Like, that's my level of performance. I know that isn't the performance of 99.99% of Node developers out there, but that's where I live, and so that's what I like to share. So here's an example. So we're just creating a server, and we're listening on a port. On connection, first thing I'm doing here is setting set no delay to disable the, I believe you pronounce that, Nagel algorithm. Now, as a quick reminder of what the Nagel algorithm actually is, when you make a TCP request, those packets are broken up into sizes, your MTU, which is usually around 1,500 bytes, right? Now, the Nagel algorithm says, don't send out that small packet until the MTU is either full or 200 milliseconds have passed by. And so if you're writing out data and the very end of your response only takes half the size of an MTU and you haven't disabled the Nagel algorithm, it will wait 200 milliseconds before sending that out. Also, in this code, I'm making the assumption that we're going to set keep alive, that this is a web page. Now, if this was like a RESTful API where people make one-shot requests, then I wouldn't be setting keep alive. Instead, I would be expecting for them to make a connection, make a request, and then end the connection, right? So that really depends on what you're doing. Now, here you can see that I'm setting the 3 callbacks for data, error, and end. Now, it does actually work this way, where I can hoist the functions out. This is a performance thing. I can hoist the functions out. Now, on data, when you get the chunk of data, that will contain the raw headers and body, exactly as sent by the client. And here's where you're going to do your parsing of the raw data. Now, remember, in Node, that the this of these functions is the actual connection object instance. So as we'll see, you can just call this.write, this.end within those hoisted functions, and it'll work just fine. You don't need to embed them in the onConnection callback so that you can reference the C variable there in onConnection. Now on air, those are important to handle. There are a lot of things that happen like handling econ reset, where like in the middle of a connection response, the connection just hard closes on the other end. That will throw an error. Those need to be handled. And then on end, make sure you clean up all your resources and close down your site, or else you're just going to have an open socket and be wasting resources. Now here's a small graph. This is a single node instance running on a 512 megabyte DigitalOcean droplet, right? So it's pretty low powered, but I tried to simulate as close as I could real world throughput on like a RESTful API call, right? And as we can see, at the beginning, they're pretty much the same. But at the bottom there, you have simultaneous requests. And as you can see, when you get like over 200, 250, you're pushing around 800 additional requests per second by manually parsing those yourself, right? Now, for high traffic websites, that can mean 2, 3, 4 less servers, right? And those servers can cost a lot. So, matter of savings and making me happy, because I know that you have made your application as fast as possible. So, also there's this idea of reducing the number of requests by concatenating sets of dynamic content. And you can do that by basically creating a hash map of segmented pieces of data. Like, for example, we saw earlier, there were 17, 20 JavaScript files and like 10 CSS files. Those could technically be concatenated, right? And be sent out down to the client in one request. So here is a very basic, very basic example, just to get the point across, of using this, this idea of concatenating sets of static content as requested by the client on the fly. Basically, when your application starts up, you read in all the files from your resource directory and say for each template you have a specific CSS file and or JavaScript file. And so you can read those in. And remember, buffers live out, those will be read in as a node buffer, and buffers live outside of the V8 heap. So if you have a machine that has plenty of memory, you can go as high as you want. It's really not an issue. Now, the on data, this is from the TCP socket example. First thing we're going to do is use the Cork API that's going to be coming out in Node.12, and then say where that second comment is. Basically, we do some quick parsing, we make an API call, we figure out what resources are needed, and then we just loop through and do a write on all the segments of content, and then we do an end at the very end, so they're all written out in one giant, as if they were one big file. And so each request could technically have a unique set of static, like pieces of static data, but they're written out as a single large file to the client, right? And if you hook up a CDN in front of that, your performance will drastically increase instead of trying to, either push down the full 1.5 megabyte JavaScript file that contains all the JavaScript for your entire site, or returning, like we saw, 17 JavaScript files individually. Now, addressing the fact there's no default compression, here's a very simple example. So we're going to say that the object, or the object variable is a JSON object from a RESTful API call that we made to some other service. We're going to go ahead and gzip that sucker, or we're going to set the proper headings or headers, and then we're going to send that out over the pipe. right? That will allow us to properly compress our content before sending it down. In my test, I was showing around 50% decrease in size. But unfortunately, it does have quite a big hit. So I just ran this for 250 simultaneous connections at approximately a 1 kilobyte response. I made it very small in response because I was more interested in the CPU hit overall. And so when I gzipped it, I was only getting 980 requests per second on average. And when I just did it plain text streaming, I got about 1,400. So to be honest, probably the most performant way to do this is to use an external method of gzipping your data. A lot of times, like you'll have a CDN or something in front, and or like any resource in front that can just gzip that data as it's going out. Node is good. This is one area where it falters in terms of like what other libraries can do, and I would say take advantage of that, get that data compressed as it's going out. And final thoughts. I've addressed very few things that can be done to optimize your applications. Node has many ways that I haven't addressed that can be optimized. And I never want it's fast enough to get in your way. Like, yes, making sure it works properly, that your tests pass, that it's stable, those are important, right? But saying, well, it's fast enough is like saying, well, I don't want my site to grow, right? Because like, yes, I can handle all the requests that I want right now. But then say suddenly you're running a site that gets put on Reddit or Slashdot. I mean, plenty of websites have been Slashdotted, right? Where it's up 1 second and down 10 minutes later because it gets a huge flurry of requests. And then my last thing would be, while programming in Node, to be creative. Many of my best optimizations, especially in Node Core, have begun with even the Node Core team saying, that's not possible, you're insane, there's no way that can work. And then I go off in my own little corner for a few days, and I cram it out and then show everybody and be like, no, actually it will work. Like, we can do this, and it's reliable and stable. It just took a little creativity. But be creative with Node. JavaScript is a fun language. You can do things in a lot of different ways. And that will allow you to figure out not only your most comfortable way of doing things, but also figure out new ways of doing things, things that you might not be comfortable with, but yet are fun and exciting and different. So thank you very much. I hope that some of this was helpful to some of you.
Thank you, Trevor. All right, thanks, Trevor. So we're going to take a break, and actually, since we don't have any lightning talks tonight, we're going to have to just come back at 8:10. We're running a little bit late now, but we'll make it up after lightning talks. Starting up again at 8:10, 2 more talks. We have Eric and Guillermo, and then we'll have a quick break, and then finally the Q&A panel with all the speakers. See you in a little bit. Testing. All right. Great. Welcome back, everybody. We're going to continue. We're going to continue our event with two more great talks. First up, Eric Toth. He's going to talk about Node.js at scale and how to use it at PayPal. And then we have Guillermo talking for another about half an hour. And then we'll take a quick break. And after that, we have all the speakers back up here for questions. So we're not going to take questions during the event, but right after you'll have your opportunity to ask questions. We'll set up a mic right after up here, and then you can come and ask your questions. So take it away.
Great. Thanks, Peter. Thanks. Whoa. Thanks. So my name's Eric. That's me. So I'm an engineering manager at PayPal. And I think Dan alluded to it earlier in his talk. We've been working with Node for a couple of years now, getting it as a first-class platform to build applications. So I'm going to talk a little bit tonight about Node.js at scale. And I know that that's a little bit ambiguous. I think Node.js at scale, what does that mean? And in fact, for getting Node into PayPal, it meant a lot of things. But I think the main things that it meant for us were scaling across 3 different dimensions. It wasn't just technology. It wasn't like, oh, we can pick a technology and just roll it out, everybody use it, we'll build awesome products, and Bob's your uncle. You just move on from there. What it actually meant was that we needed to figure out how to scale Node again across people, educate a whole lot of people in JavaScript and Node best practices. And that meant transforming C++ and Java developers into JavaScript developers and Node developers, as well as bring front-end engineers who are well-versed in JavaScript, but didn't necessarily have a lot of experience building server-side stuff in Node and understanding the Node ecosystem and what it really meant to build applications in Node. It also meant that we needed to look at our processes. A lot of processes were defined around Java, around other stacks, and were built specifically for those stacks, where when you brought Node, there wasn't really an analogous, a proper fit. So what did that mean for how our processes were built over time? And then finally, we could really address the technology and see how can we integrate Node into a lot of proprietary stuff that we run and a lot of not proprietary stuff, and where we could take advantage of what teams have done before and where we need to forge new ground. But unfortunately, when you come to talks like this, people just want to see technology. They want to see code. But I think one of the better things about the Node community and about how you think about software and you build software in Node is that it's only partially the technology. A big portion of it is around bringing new people into the fold, bringing new engineers into understanding how to write JavaScript and Node JavaScript, and mentorship. And that's, I think one of the most interesting things about the community for me is that there's a very concerted effort put towards bringing in people that either don't know how to write code in general or just never tried it, and embracing them and saying that this is something that's for everybody and you can build awesome stuff. And Dan had mentioned things like Node bots, the Internet of Things. Like, people can build stuff, build anything they want with a very arguably straightforward language. I don't know if you want to start that. Yeah, really. But it's approachable, and the Node community has made it more approachable, in my opinion. So even though that the first 2 phases are kind of the boring part because we want technology, I'm going to talk about them a little bit, at least how they pertain to PayPal and some of the things that we've worked through. So first of all, scaling people. And when you say it like that, it sounds real weird, but it's about growing people, and it's about educating people and making people comfortable working in this environment. So there's the old analogy, teach a person to fish, or give a person a fish, they eat for a day, teach whatever. It was very coincidental that while writing this, I remembered that my buddy John Charles wrote this bot that slaps people with trouts for Slack. It was very strange. This isn't to indicate that I actually taught John Charles anything. He actually teaches me stuff every day. But it was something that reminded me, like, when you have a team that's tight-knit and people teach each other all the time, it's just an incredible ecosystem which you can grow and your team can grow, and you can do things like slap each other with fish over Slack. It's pretty awesome. But that's all to say that writing code isn't enough. And in the macro level at PayPal, when we had to train hundreds of engineers, that's one thing. But then now I'm a relatively new engineering manager. I realized that it's not enough just to put them in classrooms and say, learn this stuff and let's go turn out stuff. It's really important, and again, I'm going to tie this back to the Node community, that there's this notion of mentorship, and there's this notion of helping everyone around you grow, because when everybody grows, the whole ecosystem grows. So just kind of a wrap up to the people thing, something that I've instituted in my team, and I'm hoping to be able to roll out to other teams in PayPal, is kind of this 2-phased approach. And if anybody likes the idea and wants to try it on their team, that'd be incredible. One is riffing off of the Learn You concept is every week I allocate for my team a certain amount of time to learn a new technology. It doesn't matter what it is. Just learn something, because anything you learn can be somehow applied back to your everyday work. So we do things like learning Elm, like learning Rust, like learning Angular, any front-end frameworks, React.js, that type of stuff. And then we talk about it at the end of the week. We see how can some of these concepts feed back into how we work with Node, how we work with other organizations around or teams around the company, what that looks like. And then, so that's every other week. And then the alternating weeks, I've challenged my team to contribute code to some project that either you're passionate about or you use on a regular basis. And this is something that's been huge in the Node community for me, and it's directly taught me how I can not only contribute just by putting my own code out there, but I can contribute by reading other people's code, understanding how other people solve problems, and then taking that and wrapping that, either contribute directly to that or wrapping that into how I solve problems and ultimately build better software. So as far as wrapping up the growing people aspect of it, I think there are very constructive ways you can help your team directly contribute to the Node community, which is exceedingly embraces anybody who wants to contribute, but also add value to them personally and your team as a whole and make your team just operate better. So moving on from that, the second point, the second boring point, I guess, is scaling process. And this is not to indicate that process always has to scale up. In our case, actually, process is scaled down. And Node was one of those factors, and in fact, it was a bit of a catalyst for some of the things that scaled down. So I'm going to talk about a couple of specific things that happened for us at PayPal. This is not to say that JVM expertise isn't important. In my experience, I've observed that sometimes there are JVM experts that exist merely to wallpaper over the fact that engineers don't necessarily pay attention to performance when they build applications. Performance is a value add by another organization after an application gets built. That can't hold true with Node. Engineers need to understand the consequences of the decisions when they write software. They need to understand, maybe not quite to the level of Trevor. That's pretty awesome, but I don't know that it's generally applicable. But they definitely need to understand that when I'm writing code, when I'm interacting with a network resource, with the file system, doing anything, just we were talking about maybe some system level stuff isn't the right fit for Node. Engineers need to understand that there are certain consequences of decisions and that there are some things that are not a natural fit. But that's OK. I don't think it's right to expect that engineers can just bang out code and then somebody else can clean up after them. So I think part of the process thing is making the process of educating engineers, understanding that there are consequences of decisions, and that right design is right design. That doesn't even make sense. But that thinking about design before you start coding has a meaningful impact. And you can still build great software, and you don't have to have these other guys that come along and clean up for people that just need to meet deadlines and just, I don't know, check things off their list. So that leads me on to the next thing, and this is not an anti-Java thing. This is just from multiple Java shops that I've worked at. I've really seen that if you have platforms that take a lot of time to deploy and a lot of time for applications to start and a lot of time to prime caches and a lot of time to do all this stuff, you start designing your system to have to avoid doing things like restarts. And one of the things that the Node community embraces, and it's generally by virtue of the fact that you have small processes and very discrete things that applications are intended to do, you no longer have to worry about accommodating 10-minute, 15-minute startup times. You can write applications that are very good at that thing that they do, and they can be resilient to some types of situations, but they can also fail and restart very quickly and take traffic without much of a hiccup, if any. And this is really just about controlling complexity. There's nothing wrong with hot swapping things, about flushing caches and reloading caches. It's not a bad design. In a lot of cases, that's good design. But there are so many times that complexity is added to counter problems elsewhere in your stack, like it takes 10 minutes, 15 minutes for applications to start up. Notwithstanding that, especially for developer experiences, if your app takes 10 minutes to start up just when a developer is trying to do their work, they're not going to get anything done during the day, especially when you talk about the back end and front ends, where engineers are trying to write HTML, JavaScript, and CSS, but they're bound by, I got to bounce my server because I made a change. That changes the payload that I need, and now I go take a coffee break. And then the last kind of big thing that, I guess it's not the last, next to last kind of major thing that I've noticed, which I think Node has been a little bit of a catalyst for, but it was already happening to a certain extent, is, and again, this is a PayPal, probably somewhat specific to PayPal. For people at small organizations, you probably don't run into this. But there can be a lot of layers between you and where your code is actually running in production. There can be situations where you hand off some artifact, and then it goes into a black box, and you find out, OK, it's running in production. Go check this system to find out how it's performing or whatever. And there's been an incredible, relating back to specifically at PayPal, this great renaissance of developers have the control of their own destiny. They have control of their deployment. They have control of the code that goes out. They understand all of the processes, all the steps that happen between when they're ready, they build their artifact, they deploy it, it runs. They can see everything in that process. And it gives them a lot more freedom to understand, again, tying it back to the understanding what your code is doing in production and having ownership over things like performance. When you can see that transparently and you don't have these layers in between you and your code, it's really easy to feel empowered to do something about it. And then finally, this is, I don't know if it's a process thing, I don't know what it is, but moving from Maven to NPM is kind of a big, it's kind of awesome. And there's a little shout out in there to Kappa. So at PayPal, we run, we haven't yet migrated or done the beta test for NPM Enterprise. So in the meantime, we've run our own registry, and we use a thing we wrote called Kappa to proxy requests. So we publish all of our private modules to one NPM registry, and then Kappa will check that registry for a module. If it doesn't exist, it'll then check public, which gives us nice separation between where our proprietary code lives and public NPM. And it turns out that for a lot of use cases, that's really good. And in fact, for us, excuse me, just to kind of get an idea of the scale that people are working in Node at PayPal, right now, Kappa is serving, and it may be up because I just grabbed this number about a week and a half ago. We're serving about 500,000 pages, sorry, 500,000 packages, Node modules per day through our private Kappa instance. So there's a lot of installs, NPMIs going on. There's a lot of builds going on that are installing packages. And there's a lot of people that are publishing packages to our private registry. So I think, you know, it's been a really interesting observation to see how processes, these big processes that put a lot of people between you and where your code goes, have started to erode to support being able to iterate quickly, like Dan said, to be able to observe and understand performance implications, and really just build applications very, very quickly. And in a lot of cases, fairly robustly. These applications are pretty good. So finally, scaling, now the technology part, which probably everybody is here to talk about or hear about. So scaling Node.js. So I doubt anybody knows me personally from my involvement in the Node community. Maybe some do, but PayPal had introduced, it's been a while now, maybe a year and a half, this kind of frameworky thing that sits on top of Express called Kraken.js. So Kraken.js was our attempt to help scale Node across our organization, not from a performance perspective, but take some of the tribal knowledge out of setting up web application servers and make it a repeatable process that you could have a predictable application by default and let application developers focus on building great products and not think about wiring up all the low-level details that it takes to just get a baseline robust server going. So, so that happened about a year and a half ago. We're definitely making progress. We're not still stuck there. Right now, we have about 30 web applications running in production. Some notable examples are our homepage. It's not yet at 100% traffic, but they're ramping up right now. Interesting kind of hand-wavy stat that only because I don't think I can say actual numbers is that they're on a trajectory to use about half the number of servers that were needed for the previous version that was written in Java, which is a pretty awesome feat, especially since traffic has grown since we were running in Java before. And that's actually prior to any optimization passes. They're right now at the point where they're running optimization passes over their application and focusing on very specific bottlenecks. So that's been a really encouraging thing. Things like the consumer or customer homepage, my account page, so you log in, 100% US. I think I wrote it down, maybe not. US, UK, and Germany, I think. 100% of traffic all running on Node. So we've got, a couple of applications running on Node. We've got a couple of people that know how to write apps. We've been able to scale it pretty well, but there's definitely been hiccups along the way. And I'm not sure, I'm going to say it, that I think other than actual programming errors, the lion's share of issues that you run into with scaling Node all come back to some form of back pressure. Whether it's CPU constraints that you have, it's basically resource constraints based on decisions that you make. So I have a lot of network connections, and my downstream services can't handle the load. So I consume resources just by virtue of the fact that I have thousands of concurrent connections open. Or I'm doing a lot of template rendering, like Trevor mentioned. So my CPU is bound by some work that I'm doing that really has nothing to do with my core business value. It's just something that's a side effect of needing to render pages or whatever. So one of the things that we're trying to focus on is finding ways to address those bottlenecks and allow teams to still build applications quickly, but help fix some of those potential pitfalls of back pressure. So one of the things that I've been working on recently that hopefully is going to be rolled out is this module called Levy. Now we're going to get into code a little bit. So if anybody's familiar with the circuit breaker pattern, this is based off of actually an existing module out there, and I'm going to look at his name quickly. Well, I guess I can't. I'm not going to bounce out of this. There is a Node circuit breaker module that this is heavily influenced by. It's really good. I just had another direction that I wanted to take, so I decided to try my hand at it. But what a circuit breaker pattern is if I have an application that's talking to services, actually, before I go on with that, circuit breaker in Node, and actually Netflix's Hystrix is a Java JVM-based implementation of this same pattern, which is pretty awesome. So this is just my crack at making it for Node. But basically, if I have a service that exceeds its SLA on the client, I can observe, let's say I have 5 requests timeout. I can actually trip this circuit breaker and put it into an open state, meaning I will fast fail subsequent connections for a certain amount of time. After a certain amount of time has elapsed, I will allow a single request through as kind of a smoke test to see if that application is recovered. If it has, great, the breaker closes and I resume traffic. If it hasn't, I go ahead and reset, and then after a certain amount of time, I try again. So this is a really interesting way of dealing with back pressure, where instead of just timing out and keeping a ton of connections open, or the application goes down and I just get thousands of econ reset errors, I can actually set up a fallback mechanism that allows me to put in a fake payload or some sort of message that I can use for my internal clients or my code in my application, but also doesn't repeatedly hammer my APIs or my services such that they can't recover. It takes the traffic burden away from them. So if they need to be restarted or if they're just slowing down because they can't handle that traffic, it gives them that built-in recovery time. So a quick, just very fast example of this is, so this is an example using the rec module by the Happy.js crew, Aaron Hammer. So normally you just write rec.get, and you got this thing called downtime because it's not up very often. And you get back after calling, you're getting your stats. You get an error, you get a response, and then you get the payload. So with Levy, I grayed out the stuff that doesn't change. You can wrap the get call in this create breaker. So you have this circuit breaker instance. So now you can call the same API, circuit.run, and you give it the call. And after a certain number of failures in this particular configuration, you'll still get an error message, but after those failures, the error message will say, I'm not calling that anymore. I'm just fast failing because the service is down and there's nothing I can do, and it doesn't make sense for me to use resources and keep connections open on a service that may take 5 or 10 minutes to return or just be down. So that's the first pass. But then the second pass is I can configure a fallback now. So if I had this create breaker before, I can then create a fallback that is always successful. So I don't have to then think about, well, what if it's down, I get error messages back. I may get a few error messages at the beginning until I hit that threshold. But after that, I've got a backup payload that will suffice for running my application, or at least notifying the rest of my application that this service is down for a certain amount of time. So again, this is something that we're going to be trying out at PayPal. Netflix has used this pattern with great success. And I think, when we're talking about Node and we're talking about performance, talking about back pressure being a major issue. I mean, even if you talk to the Walmart guys on Black Friday, like the Node process isn't the problem. It's the fact that it can send traffic so fast to other applications that may not be able to deal with that amount of traffic. That could potentially become the issue. So I'm a big fan of the circuit breaker pattern. I'm going to run through these next two things really quickly because I'm going a little over. But Dan briefly talked about APIs and about REST APIs and REST specifications. So another thing that a guy on my team is working on, Trevor Livingston, is this thing called Swaggerized Express. And it's a spec-first approach to building services, to building RESTful services. So at PayPal, part of the process of building a service is you define the API for that service. And you iterate on that design before you start writing code, which is really boring for people that like to write code. But on the other hand, what that means is you have a document that is the canonical representation of your API, from which documentation falls out, from which your implementation can fall out, and from which client APIs or client modules can fall out. So when we thought about it, we thought, all right, well, everybody's spending this time putting effort into building this document. How about we use that document to not only drive the generation of these apps, but then drive the validation of these endpoints, the validation of the inputs and the outputs, and continue to use that document as the canonical resource to describe the API for both clients and servers, but then also to help ensure that these apps are stable when they're being built, and then when they're running in production. So just a quick snippet of code. It doesn't really describe much, but it has, basically, you just use it with Express right now. The API JSON is your Swagger document that describes your API. This assumes that you've already run the generation step and you've built out the scaffolding for the API. You have a reference to your handlers and then a reference to your documentation. And then finally, it's a working name. I don't think Purnima has come up with I think we're still working on the name for it right now. But another thing that we've observed when running applications in production, specifically web applications, is that it's important to instrument your app to understand what it's doing in production, but more importantly is instrumenting your app to understand what business value it's adding, which means that you're potentially doing a lot more logging of specific data as it pertains to what's flowing through the app. Not is my app healthy, how much memory it's using, but is my app actually fulfilling the metrics that the product team has established for what it should be doing. So when you're talking about doing a lot of logging, we have a lot of services that are socket-based, that are REST-based. I guess none of that matters. What matters is, what we've observed is people will either write these giant JSON objects, or they'll write a lot of code to pluck individual values out of these gigantic payloads in order to do this type of reporting. And some teams just hand roll this property on this property on this property, and they write this really brittle thing that traverses this giant JSON structure. Some teams use an existing implementation of JSON path, which unfortunately is the source of some CPU contention, very heavily regular expression-based implementation, and also does this parsing of the selector and the evaluation of the data in the same step. So what Purnima came up with was something that breaks that into two steps, and you use the selector to compile an evaluator, and then at runtime you run the evaluator over your object, meaning that we can get these giant payloads back, JSON payloads back from our services. We can write a selector that plucks off individual values from that payload, and then just logs what it needs with as little CPU overhead as possible, and more importantly, less brittle logging code spread all over our application. So that's just a quick example of transposer.create. So you created your implementation based on the selector, and then at runtime, you just run it over the data that you want. And just a couple of stats for what she's been able to do with it. The existing implementation that the team is using for, so this is recursively select any property with a name ID is what this top one is. She's been able to improve it. This is her module. This is the existing module. And we're hoping that that, again, bringing that back to the Node.js at scale, to be able to grab data at runtime, do logging without any or minimal effect to the customer experience. Hopefully this will help us get that far. But anyway, so that's all I have. Kind of rambly and quick, but hopefully it gave everybody some insight into kind of how we've been able to scale Node at PayPal.
All right. Thank you, Eric. Cool. So Guillermo is just getting mic'd up here. Once again, so another about half an hour. Take a quick break after that, and then we'll do the Q&A with all the speakers. Are there any quick questions for Eric while we're setting up? Eric, come on back. Any quick questions here? Yep, go for it.
Yeah, so you mentioned a little bit seeing like a performance increase moving to Node. You were kind of talking about like less servers, things
Yep.
like that. I kind of that kind of baffles me a little bit, like moving from JVM to Node and seeing a performance increase. What do you describe that to? Like, is that
Repeat the question.
So the question was, I had given this kind of high-level statistics of it's been taking less machines to drive the Node implementation of a particular application than it had the JVM. The specific thing that I attribute that to is that the application did not a ton of business logic, but really the logic was around around composing pages. So it was very amenable to large caches and just literally writing buffers out to the response. It made some service calls, not as many as our other heavyweight applications, but the fact that it's a small plug to Kraken, but the fact that it's based on a very lightweight thing instead of, to say that it's faster than JVM makes a lot of assumptions, right? Like you have frameworks built on top of frameworks in any platform. For our particular implementation, the fact that that Kraken was lightweight for what they needed based on Express, that it was it didn't provide any features they didn't need. It just inherently had a lot of less overhead to do that specific task. It wasn't necessarily, it was, it could mostly be attributed to our implementation on top of the JVM, but it was just an observation that for our business, half the servers is half the servers. You can't, it is what it is. But it was a little hand-wavy, I agree, and it really depends on your implementation. It depends on the stack that you build within your organization. But as a direct port for us, it was a really big win, at the end of the day. So, cool. All right, thank you.
Any other questions? Just hold those until the end of all the talks. We'll do a Q&A with all the speakers. Take it away, Guillermo.
All right, thank you so much. So my name is Guillermo Rauch. As I was introduced earlier today, the creator of Socket.io. I was involved very early on with the Node.js community, working on everything from trying to bring the core APIs to a point where they were useful to us at our first startup, all the way to creating new frameworks and supporting existing frameworks. We worked with some of the greatest Node.js people like TJ Holloway-Chuck and Nate Rockledge, Marco Aurelio. And today I'm going to talk about something more encompassing, something more generic than just Node.js, specifically about real-time web applications and how I look at real-time web applications. When I was just thinking about the title of my talk earlier today, I started thinking about how we don't have a definition for it, or how when we say real-time, we all think maybe about different things. And some of you might think about WebSocket, some of you might think about, for example, data that refreshes over time, maybe regardless of how we convey or move that data from different points. So I'll start by talking about a definition that I've come to after working with lots of different web applications. All the way before Node.js existed, through Comet, and all the things that we want to do with those technologies. So the first conclusion that I've come to is that when people think about real time and they think about actually just moving data really fast, they think about refreshing data with minimal latency. So it's all about the user thinking that the data is not stale, that what they're looking at on the screen is a representation of the latest and greatest that's available on the server, and that that's coming with minimal latency. It's coming really fast after it gets to the server. So if you're chatting, someone sends a message, we want to get that message to someone else as fast as possible. And the other really important aspect is that that data to the user has to update automatically and uniformly. So automatically means that they're not pressing a refresh button, for example, or they're not keeping track themselves of updating that data. And the other aspect of it is that if a portion of the screen that comes that's representing some data on the server updates, and then there's another reference to that data within the same application, both are synchronized. So the data updates everywhere. And that all comes down to you write a web application that does never require that the user presses F5, for example. And what I like about this definition is that it's actually pretty easy to summarize it into two things, despite all those long explanations. So your real-time application needs to be fast, and it needs to be self-updating. So I'll go with this definition for the rest of this talk, and just to put it in context of an example of an application that you might write, I thought about a traditional real-time application, which is a stock ticker showing the value of a stock in real time. And I'll start with some simple HTML, which has some representation on the user screen. And then we add some naive JavaScript to make sure that's up to date. Usually when we approach the problem like this, it's hard to decide on what timer we're going to set on the front end. This has been a long subject of debate. For example, when you implement long polling, is how long does the polling duration need to be, or how fast do we need to try to get more data from the server? So we'll just go with 15 seconds right now. And then we assume that the server, at the start of this timeline, thinks that the price is 500. And disclaimer, I don't know what the price is. I just came up with this. So the user goes to the page, and then, of course, we're going to request some JSON API. We're going to get that the price is 500, and then we wait 15 seconds, which, of course, is completely arbitrary. At this point is where this application sort of breaks down and stops being as fast as it could be, because the price might have changed, but your front end will keep waiting. And see, it's Friday night, and it's really slow, and no one likes it. I don't like it, but we have to wait. Yeah. So, and then the front end decides to get it again, and then, boom, it updates to 505. The user at this point has no idea what the server knew, and they didn't know that it could have gotten faster. It's just your application just became slow. So in this case, the front end is self-updating. So I think this is where a lot of people might be confused with, is my application real-time or not? Because if it's self-updating, you might think it's real-time. But in this case, it doesn't satisfy the other condition that we set. It's fast, and it's sad, and it makes me cry. So the next thing you might think is an optimization. You might think, oh, Guillermo, you said 15 seconds. It could have been just immediate. So now, boom, it's fast and self-updating. So even though it's fast, or it might be fast, as I'll show next, in fact, just because you're requesting data from a client to the server, it's not as fast as it could be, because the server is really the source of truth of this data. So the server is the one that first finds out about the latest price, and technically is the one that should let the client know. The client doesn't need to ask. But by performing this loop of GET requests, we also have a side effect. That is, we increase latency by having to ask all the time, and then, of course, server resources. And the natural conclusion was that it's much better to have the server push data to us with, boom, socket.io. Let's see it again. Boom. Beautiful, right? No. So you're like this at this point, but yeah, I actually have come to the conclusion that push is also not necessarily part of the definition of a real-time application. And I like to explain it with an analogy, which is you go, and this is you. This is why it has a body. And you think you're hungry, and boom, idea. Let's go to $7 Coffee Cafe in Mission Dolores. So the analogy goes like this. You go and request the menu from the server. So this is the traditional, this is the way that I usually explain the traditional request-response model. You just sit there, you get something, you get some response right away. So this waiter is kind of weird, and he goes, 200K menu. And then he goes back to whatever he was doing. He idles. And this is what Node.js is good at. It's good at idling and handling all these request-response cycles. And you're like, I know what I'm going to get. It's a bagel. And in this case, there's no response. HTTP is a great protocol for modeling this. It's just, OK, I'll let someone know. The metaphor is really good. Then I find out that the kitchen is actually a web service. So the guy goes and goes, bagel, OK. OK, and then idles again. So this is where I think the web sort of disappointed us, in which if we were expecting some update from someone else, it was usually really hard to do. And what we've been doing up until this point is always asking. So you become really upset, and you're like, what's the status? And then you incur more load to the server because you need to check again. The kitchen gets really upset because they're like, dude, we're still working on it. And the guy is still pretty chill with his glasses, and he's OK. And 1 second later, boom, here's you again, asking again. And this is kind of like our stock ticker example. You're like, yeah, I'll just ask again. There's no problem. But then what happens, there's other people that are interested in consuming this service. They all look like you, too. And it results in server congestion. This is a single-threaded JVM, and it's really bad at handling many things. So what's the solution? Of course, is that we push updates to the client without the client requesting. And in this case, it models back to like someone announcing something and delivering it to the clients, which we call events. And this is how we think about it in Socket.io. But I'd like to make the distinction that it's technically still not required that you do push to satisfy the two conditions that we set. So one of the ways that people have circumvented this, if you reduce proximity from the client to the server, so you minimize the latency, then in this case, by having the waiter right next to the guy, then you might think that your application is real-time just because the latency of the request-response cycle is so low that to the end user, it's real-time. And the other thing that you have to do to make this work is you have to increase server capacity. So it would be equivalent to having tons of capacity just because you're expecting so much more load. So if you do these two things, you do effectively have a real-time application. And then that like naive example that I set up would actually work really well. So what I want to point to with this is that real-time is more about the user experience. It's not so much about what stack you decide on or what transports you're using. So there's two implications that I've thought of that come with setting up an application that is both fast and self-updating. So as far as making your application fast, the speed at which you basically make the data transfer work is going to determine how real-time your application is. And I've come to understand that real-time is more of a gradient rather than a binary classification. And an example that I remember from like many years ago when I was just getting started with Socket.io was Google Docs. There was a little startup here in San Francisco called Etherpad that defined themselves as really real-time. So this was their way of saying that even though there were real-time systems available like Google Docs, they were sort of pointing to them standing alone in that regard. And also, they were pointing to how like Google was taking an arbitrary length of time as opposed to being as immediate as it could be. So this kind of points to that first naive example that we're doing. And they give a great example of how most of the communication that we do in real life doesn't really have this sort of arbitrary latency. So at the time, I think Google satisfied the self-updating thing, but it wasn't as fast as it could be. So someone came up, a little startup in this case, and made something better, got acquired, boom, now they're in some beach in Hawaii. No, they're probably just working here. They're probably maybe here. Friday night, thinking about real time. Yeah. So one of the things they did was they switched from an algorithm of how they convert changes in the text, and I'm not sure about this one, but I think they were just polling and they implemented long polling. So they focused on making the user experience better. And the other part of the other implication that comes with these two conditions for real-time applications is that if you're going to make your application self-updating, it can't just be self-updating while the network is working perfectly or during the beginning of the session. And you have to make it work all along. And reconnection is one of the things that you have to do. So you're setting up an expectation, which is for the user, the data is always up to date and coming in, and they're not going to be used to like thinking that they need to press a refresh button. So one of the consequences is that you have to make sure that the user knows that if there's a network problem or if they're disconnected, that you're trying to reconnect. And of course, most of the real-time applications that you use today, like Google Chat or Facebook Messenger, do a good job at doing this. But another thing that is really important to consider is what I call state reconciliation, or we could call it resynchronization. And a test that I run on most applications is, especially the ones that are self-updating, is what happens if I'm looking at something that's updating in real time, I close my laptop lid, and I come back to it a week later. I just open it, and what happens to that session? And it turns out that the front end needs to keep a few things in mind that maybe we're not used to thinking about. One of them is that the session could have expired. So the application needs to know how to re-render itself in a logged out state, for example, dynamically. User login change. So there's a chance that maybe from another tab or you invalidated this session remotely, so you actually have to repaint the screen with a completely different user. Or, more concerningly, you might have been offline for so long that the delta is really big. And in many cases, it's not even worth showing entirely. So there's a lot of systems that make your application satisfy the condition of being self-updating by ensuring that they synchronize every change that happens over time to any data that the user is looking at. But then they're going to hit a problem when you're offline for a very long time because of two reasons. One is you might overwhelm the user with data. But even if the user can handle it, it might not even be relevant. So if you're offline looking at a Twitter stream or a Facebook stream for a very long period of time, by the time, I know, a week has passed, it doesn't even make sense to get the entire diff. You might just want to get the tail and also handle it appropriately on the front end. So the conclusion is also that you have to be careful with designing it around an event log of sorts, where if the user is subscribing to some data, your front end assumes that every subsequent change without fault is going to be retrieved. And finally, I'd like to mention an important caveat that comes with basically designing this type of application, or I should say, at this time, it's sort of a risk that a lot of us run into. So I think in the effort to making our web applications feel alive and self-updating, because it's so rewarding to the user and sometimes so rewarding to the developer, we've forgotten that we're actually maybe making it fast during the lifetime of the session, but in the beginning when we were loading our web application, it's actually really, really slow. So a term that I object to as of today, because it dawned on me today that single page app is a really bad name for what we want to do, because in some cases it implies that we're giving up server rendering. So there's only one page, which means your server handles every URL the same way, which is not good, and we're going to see why. In most cases, this type of application incurs in too many hops in the network to give the user the data he wants. And in many cases, they also give up the information that they have of the URL. If the user comes to you with a certain URL, you already can prepare the data that he wants to. You don't have to download a huge single-page application script, then evaluate it, then get the data. So, and I think this happens a lot because there's a lot of progress being made in the frameworks that we use. So React.js, Socket.io, all these frameworks are really exciting, but we're forgetting about basically how that first request works. So a useful reminder is that we're all operating under the assumption that TCP is how we establish that first connection to the server, and that's how we get the data. Google is working on making improvements to TCP and coupling it in such a way that it works better for speedy connections. But for the moment, we have TCP as the foundation of everything we do in real-time web applications. The data is sent in segments over a sliding window that acts as a congestion control mechanism. And we have to keep in mind that data is sent to the user in a growing way. So initially, it just is only able to send 4 segments. And I like always stealing this slide from Paul Irish that points to how much data the client is able to absorb over time for every TCP connection. And then he has really interesting numbers for the equivalent in 3G connections. And it kind of shows, it kind of puts into perspective how bad it is to make the user load all these huge single-page applications. The conclusion is that the first 14 kilobytes are the most important to make the application feel really fast in that initial load time. So my conclusion is that the most optimal real-time application will have to necessarily render data on the server, or at the very least, render a placeholder of where you're going to fill in the data. So part of it or completely, you have to render data on the server, and it's not a choice. So I think when I was asked to talk about the future of real-time applications, I think most of the future will have to do with investment in making this faster, because we've made the lifetime of the application fast. Like once everything is loaded, everything is super fast and self-updating, but that initial connection is actually pretty slow. It's very important that the client side then takes over once that initial server render happens, because if our goal is to minimize latency and make the application really fast, JavaScript is uniquely positioned to do that, because we can even mask the actual network latency by using JavaScript in the client to make the front end behave optimistically. And an example that I always mention is you write a chat application, and it doesn't matter how optimized it is. It doesn't matter that you use the transport with the lowest amount of framing, like WebSocket. At the end of the day, most applications will actually insert or repaint the screen once you hold down your Enter key, because that's the best user experience. They're not just waiting for the network. So basically, we do need this basically initial really fast server load, in many cases with server rendering data, and then we have to have the client take over, because otherwise we're giving up on these really amazing optimizations and opportunities to mask latency. So even if the network is terrible, client-side JavaScript will always make it better. So the consequence that I was mentioning earlier, or the implication that we have to be really mindful of reconciliation and reconnection, is even more important in this case, because you have to think of the server rendering some data as basically a connection that disconnects immediately, then the data gets transferred to the client, then the JavaScript loads or whatever, and the connection gets started up again. And then at that point, there is a chance that from the moment that the server rendered the page, data could have changed. That's why you have to always think of these self-updating applications through the lens of the worst-case scenario, which is there's a lot of disconnections and reconnections. And to make this seamless, I think this is sort of the conclusion, is the ability to share code is going to be uniquely important. So the future is what it's always been about, I think, which is make your app deliver data faster. And I think running JavaScript on the server with Node.js is going to be really helpful for that. Thank you.
Take a 10-minute break and come back here for a Q&A with all the speakers while we reset the room real quick. Okay. All right, we're going to get started with the Q&A session. So if you have any questions, there's a mic right there in the middle. And if you can just get up there and ask your questions, that would be great. After, in about 20 minutes or so, we'll do the raffle. And then for sure by 10 o'clock, we need to be out of the building. So, oh, we have one quick mini lightning talk. Sorry.
Hello, everyone. How you doing? I'm Tristan from Hitch. We are a ride-sharing service in San Francisco, similar to Lyft and Uber. We started 3 months ago. Last week was our 3-month anniversary, and we've been growing every week. I'd just like to invite you all to try us out if you haven't already. We started 3 months ago with the idea of starting a rideshare company that was cheaper, that was more social, and that was more benefit for the environment. The trick is every single ride is a shared ride, so you're sharing your ride with other people. You can connect with them on Facebook, on LinkedIn. You could also have a more romantic connection if you wanted to. So the idea here is you connect with your neighbors. You rediscover your neighborhood. We've had people that share a ride with people that were their next door neighbor, and they'd never met them before in 10 years of living in San Francisco. I picked up someone, and we went over and we met someone that was their high school friend from a long time ago. We met someone that was a business owner, and he was actually able to make a business connection in the car. Someone has actually gotten hired in a hitched car. So definitely try us out, iPhone only. And yes, these are out in the front, and they have a promo code on the back, HitchSF. I think there's a Node.js. If you put Node.js as a promo code, that's your free ride for the night. All right, thank you guys.
All right, so free ride with Hitch. Romantic ride after. Right? Right. Wait, well. All right, it's worth a try. All right, so we've got a couple questions over here. If you have a question, just line up over there. I see a couple people already there, so go for it. Take it away.
Hi. This question's probably for Guillermo, but anybody else, maybe if they have some opinions too. So I have a pretty large application which has users and communities and things like that. Once in a while, a user will go onto the page which says like list all the users in this community, which in the novice sense emits a whole lot of get XHRs, like one for each user. I've turned that into a batch request to get all of them at the same time, but it still is going over the regular HTTP connection. But I also have socket.io running for real-time updates. And I was thinking about it earlier today. I was wondering if it made sense in any way if the socket.io connection was actually a WebSocket connection to route some of these XHR requests that would normally go through the regular HITIP connection. Is that a sort of thing that would be stupid?
Yeah, definitely. I've seen a lot of people do... I mean, if you're using Socket.io, you're doing it right, so definitely. No, I've seen a lot of people do this, HTTP over WebSocket. I think when it comes down to specific optimization, like the one you're mentioning, there's a lot of things to consider. One of them is, if you're making tons of XHR requests in parallel, Speedy solves this problem really well, because it allows you to push resources, it allows you to multiplex, it also does compression. So by turning on Speedy, you might get an immediate win there. The other thing to consider is, of course, on the other extreme, which is ditching HTTP requests and just requesting them through some sort of event or RPC call of sorts. So I think that thing that's most important there kind of goes back to what I was mentioning earlier is on that page, you sort of know what requests are going to come. And it's optimizing around that. Maybe not so much optimizing around the client requesting, but the server sending without the client requesting itself. Does that make sense? Okay. Anyone want to add something? Yeah. Maybe say definitely?
Definitely. Yeah, and I think Guillermo touched on the point that I was going to add there, that the routing for the responses could, you could find a lot of efficiency by having those be routed back to your app with Socket.io. So yeah, you would have response events and sort of dynamic events all coming through the same channel.
All right, probably for Eric and Dan, excluding some of the optimizations that Trevor talked about, I would like to know the ratio of front-end programmers who become fully functional full-stack programmers versus the more server-side Java, C++, .NET, whatever sort of experts who then become functional front-end people. So it's the ratio of one to the other.
Very complex question. All right, so there's two questions there. 0%? Okay, 0%. No one needs to be full stack. All right. I wanted to highlight that on this panel here, there are at least two front end developers who've become back end developers, and that would be myself and Trevor. 50%, right? And then were you back end first?
I don't remember.
Full stack.
I was front end and back end, but JavaScript got me interested in, I think, optimizing the entire network stack. And I think that's a cool opportunity with Node. You might start with, or JavaScript in general, you might start with something very, very front-end based, and then do whatever you want, like control a drone, or Arduino, or write an entire OS TCP stack in JavaScript. So, 0%.
Specifically for Eric, within PayPal, you probably have some data points here. Front-end people who became serving their own data versus people who were responsible for serving data becoming front-end people.
Yeah, it's an interesting question. I think, first of all, full stack changes depending on where you go. So when I think full stack, I think front-end developer, I think web application, what did you call it? The back end of the front end, the back end front end engineer, front end back end engineer, the mid-tier engineer, and then somebody that knows database level stuff. Like that's full stack for me. So if you break it down that way, I don't know that we have any I don't think we have any full stack engineers at PayPal because we have a service-oriented architecture, and we intentionally segment people that have those disciplines on purpose. That said, if you're really talking about mid-tier, potentially mid-tier or application level engineers that have, I almost said graduated, that's not the right term, but that have embraced front-end engineering, and then front-end engineering application, front-end engineers that have embraced application development, I think it's kind of an expectation that has been set, and most everyone has made that transition. One of the things that we did during that transition is we acknowledged that maybe everyone doesn't want to do this, and that's okay. And we moved that criteria down to if you just want to work on, air quotes, backend, then there's plenty of mid-tier services, applications that you can work on. But if you want to work on the front tier, that's great. Really all that is aggregating services, aggregating data, and basically transforming it into a format that you can use, and plucking off the values that are important to you and representing that for front end consumption. So I think we've had really good success in it. I don't know, there's the whole we can reuse JavaScript on the front end and the back end. I don't see that I've seen any actual. I don't see that I've seen that in practice. That's actually added a ton of value. But the fact that all of our front-end engineers understand async programming with JavaScript automatically put them a step ahead when getting into Node and understanding how Node APIs work, how talking to services work, and just the mental model around working at the back end of the front end tier. I think we've seen really good success with it, just from that perspective specifically. The corollary of seeing Java engineers that haven't necessarily worked. They may have worked in futures, they worked in multi-threaded applications, but to make that jump to async development, and not just like higher order functions or Lambda, like, oh, I can pass functions around and it looks async, to actually grokking and understanding async development has been, I'm not going to say it was a challenge, but it wasn't as natural from my experience. Is that fair enough? Right on.
Riffing on Eric's talk, the great thing about the way the stack's evolved and Node and front end JavaScript, it's really given us opportunities to be creative and sort of solve. We're engineers solving the problems that we want to, scratching the itches that we have, solving those problems. So we now can go and accomplish those in new and unique ways. Encouraging or forcing engineers to move one way or the other, I think is the wrong way of thinking about it. Giving opportunities to grow and expand your experience, your knowledge and understanding is what Node has provided, and I think that's really compelling.
Hello, my question is more about the hardware. You mentioned in the presentation that you were able to reduce the number of servers like a half, while you had all your application written in Java and you moved to Node.js and you were able to reduce the half of the server. So my question is, what is the optimal setup of a server that you will need? Suppose you have one high-end server, like 128 gigabyte of RAM, two 10 gigabit Ethernet, and like 40 CPUs. So how you would chop into the virtual machines? What is the optimal way? So you get the best performance, maybe that sweet spot.
I think that the question was predicated on a comment I made, but I think everybody can probably chime into this. My very short answer is that it has absolutely nothing to do with the hardware profile, and it has all to do with how you design the system and specifically that application. And the thing that I referenced, the particular application, the profile of that application was way more amenable to a Node stack than it happened to be for the JVM. It wasn't necessarily about the hardware profile, wasn't anything else. It was that specific app had the work that it did just was in Node's wheelhouse, and the framework that it ran on on the JVM just was a square peg in a round hole type of situation.
Question is that the Node.js uses one thread, so it's better to dedicate one CPU per virtual machine. So then comes the question: how much RAM it's better to dedicate to application server, and how much, depending maybe on network or capacity.
To address that, Node is single-threaded. So the general rule of thumb is one node process per core. Given that you're only running Node, right? The V8 heap maxes out at 1.5 gigs by default. And so n cores times 2 is way more RAM than you'll need. So if you're running 40 cores with more than 80 gigs of RAM, you're going to be like, I hardly ever see hard hit applications using more than 800 megs of RAM, right? So 40 cores and 60 gigs of RAM should run you fine if you're running 40 node processes.
Just a small editorial side note. If your application runs on 2 boxes that have 80 cores or 40 cores, you're kind of setting yourself up for failure in the sense that if one of those boxes goes down, you're kind of SOL. So I think, at least for what we've experienced, the optimum is actually running more smaller boxes. You're more resilient to any outages or any issues that may run. So I think how do you optimize gigantic hardware may be answering the wrong question in a way.
So I would encourage you to not think of your VMs as just a single Node app. You're setting yourself up for a monolith. So in each one of your VMs, you may have multiple apps multiple processes doing and orchestrating amongst themselves. So unfortunately, it's one of those sort of not very satisfying. It depends. But I would encourage you, not to, think of a single core, a single process. Let's slice it, those 40 cores up into a single process and a single VM, or two can work in some of those situations. But really looking at how each individual deployment works effectively will color how that gets carved up, and it'll probably vary from application to application what the most optimal profile of your VMs is going to look like.
Actually, I was most interesting the ratio between the network and the RAM memory. So if you have like good network, if you want to keep a big load on this one node, then how much the RAM? Sorry?
There's no ratio.
There is no ratio.
It completely depends on the work you're doing. If you're just passing data through, I mean, I'm not crapping you. If you're just passing data through on a Node app and you're handling 10,000 connections on the box, I've seen Node processes run under 100 megs of RAM, right? So, but if you're doing like template rendering and you're doing the same number of connections, you could be using 800 to a gig of RAM, right? There's no possible ratio that is statistically significant in terms of how much bandwidth you have and how much memory you need.
So best approach is benchmarking before going live?
Yes, yeah. You need to know the limitations and use case of your app to be able to determine that.
Thank you.
This question is for Guillermo and any other member of the panel. In your presentation, the issue of real time came up, and really real time. Have you considered setting real time to, say, some common denominator like 20 seconds, so that no matter where you are in the world, real time is always 20 seconds in the past?
I was going to include something in this presentation, which is the research by Nielsen on how we react, or how long it takes us to react to data changes. And I think that's a meaningful addition to how we assess speed and real-timeness of applications. It roughly goes like this. If it's under 0.1 seconds, the user has a feeling that he's interacting directly on the data. This is the case when you use Excel on a local machine. Like, everything that you do is instantaneous. You think you're altering data directly. And you sort of forget about the persistence aspect of it. And he says under 1 second, to most human beings, what happened was instantaneous. That's why I advocate for not showing spinners or loading indicators unless a significant amount of time has passed. Because to most people, under 1 second is instantaneous. I've trained myself to recognize that, for example, my PS1 variable on Bash was taking too long. It was like 50 milliseconds off. But most human beings that are not staring at their terminals all day think under 1 second everything is instantaneous. So, and then he says over 10 seconds, that's the limit at which you lose your attention span and you like tab to something else. You open Reddit or Twitch.tv and you just do whatever you do something else, or like down. Yeah, when you guys were working the previous question, it was somewhere else. No, just kidding. So I think it's there's a theoretical basis to how we can assess like how real time an application is, which has to do with so the server learns of a change on the data. How fast can we get it to users? That's why I was saying that as long as your application is self-updating and fast, and it could be fast just because you're close to the server and you're polling, right? Or even if the page was just refreshing automatically, if the right conditions are set, your application does feel real time. So yeah, I would go from that angle to assess how real time an application is. But I found that the best way to like define it has been, it has to be fast, and the user has to learn of the changes to the data without doing anything.
That's all fine for the biomechanical implications of a circuit, such as your finger taps on something, you feel it in your brain, and so on. But if we're just talking about setting the present to 20 seconds in the past, then you could theoretically bring everything that happened on the server down to the client 20 seconds in the past, and then that person would always see the present as it already happened.
I don't follow that. Maybe you do.
So we're all so tied up into trying to get something transferred from a server to the client.
Right. Oh, you're saying if the client doesn't know that data has changed, to them it doesn't matter how fast they get it? Is that?
They already have it. It's already happened 20 seconds before they got it. Before they even saw it. They already received it.
Maybe. Like data sampling?
Okay, so yeah, I've actually seen this, and I think I know what you're saying, where it was actually updating by the second what was happening, but when I look at the code, what was happening is that it was sending me chunked 5-second updates and then updating 1 second, but technically the data was 5 seconds in the past, but to me it looked instantaneous. Is that what you're saying?
Yes.
Okay. All right.
All right, so I think I think that's important because a lot of what we talk about is optimizing the experience, right? But I think the most important optimization we can make is have the power to decide, right? And that's what server push allows us to do. So even if we can get away with tricks like that, if we don't have server push, we can't do the most optimal way of sending data, because maybe we want to send it right away after the server knows. Maybe we don't. But if we have the right architecture, we can make the choice. Whereas if you're stuck on some older architectures, you can't. But other than that, I think that's answered. You want to add something?
So a couple of years ago, I went to a session on Node.js, and they were talking about SSL termination at the node tier, and that one server failing could take down or make the entire cluster compute bound. And I wonder if that's been addressed.
No. So this is what you're describing is actually a very I know the exact scenario that you're talking about because I lived it at Voxer. So that issue is in part very, very specific to Voxer's architecture. So in order to maintain the rich real-time experience, there's a lot of session affinity. So the fact that there's that session affinity, all of the SSL termination, the SSL handshakes is very CPU intensive, and so if you do tens of thousands all at the same time on a single process, and everybody is coming back to the exact same node, then you're going to be in a world of hurt. So that's a challenge very specific to that particular architecture. But the SSL termination story in Node is still not great. We've made improvements in what will be 12, but it's incremental. But typically in large-scale applications, the SSL termination is done off the process, and if you look at the proxies all the way down story, there's a reasonable argument to be made if you don't need SSL throughout your stack to do SSL termination off the process. Do you want to talk about some of the SSL termination stuff that you? Okay. Okay. Let me let Eric talk about that.
So prerequisite for everything at PayPal, obviously, is security. So we do use SSL all the way down. We were proactive in making the decision that we don't do any SSL in Node, partially because it would be a performance bottleneck for us. But as much as it's like a warm, we love the Node community type of this is how it operates thing, it actually is true. It's not a core competency of our apps. In the same way that running cluster is not, like understanding how our deployments happen is not a core competency of our apps. So like forcing our apps to do SSL, forcing our apps to do gzip, that's not an application level thing. That's a system and infrastructure level thing. So it's just worked for us. And I think Dan was alluding to some other things that we've had to do to improve SSL performance since we have an N-tier architecture and doing SSL all the way down is really expensive regardless of your implementation. But we've definitely decided that those are not like core features that our apps need to be concerned about. So we've done everything we can to pull them into extra layers. So terminated Nginx and then reverse proxy into Node, for example. Let things that are good at gzip do gzip and not force that through the Node pipeline.
Yeah, I was going to add something specifically because we do it in the same way at CloudUp and Automatic. Even from a modularity perspective, it makes more sense to always consider your applications just a vanilla HTTP server. And even if you decided to handle SSL in Node, it would make more sense to stack it with other modules or processes and wrap those servers. So in our case, we do it with Nginx, but if Node becomes better at it or we just want to do it in Node, we could. But your application should just export the lowest common denominator, which would be just listening on some port and exposing just HTTP.
All right. Well, I think that concludes our questions. So, big round of applause for all 4 speakers. And we get your special speaker gifts. That's it for the live stream. We're going to continue with the raffle prizes, but you must be present to win in this room. So thanks for everyone watching on the live stream, and see you at the next event on September 19th. So we're going to get you guys to draw the raffle prizes. So ready? Oh, yeah. Picture first. Photo op. All right. So... All right, so we've got a couple of starter prizes, some books, one of them about Node.js. And you can, when you are called out, actually, just do
numbers.
Yeah, just the last 3.
178. 178, you win a book.
All right, so when your number is called, please yell it out so we don't give your prize away. Sorry? Oh, yeah, let's do one more book. Guillermo.
Oh my God, it's me. No. 384.
384. Not here, or? Oh, okay, okay. Not here. All right, we actually have a couple of prizes for best social media. Best social media, you can come up and win a nice prize. The first one is on my phone. Jamin Ferguson. Not here? You know him? Can you give him the prize? Sure. All right, cool. Give him a Leap Motion controller. That's awesome. Yeah. All right. A Leap Motion controller for Jamin, coming courtesy of Eric. Tom Cho. All right, come on up. Whoa. And the final social media prize, so it pays the tweet about these great events. Rich Trott. He wins a prize at every event. Come on up. All right. Okay. All right. Next prize, another book. Yeah, not the
350. 350.
You have it, just yell it out.
Not here.
Awesome. 160.
All right.
What? 350 again. All right. 297.
297. Yep. All right.
All right.
Come on up. All right. So let's see. How many books do we have? 3 more. Okay. All right. Another.
284.
Do we have 284?
284. 284. Yeah, right.
303. Boom.
303 not found.
296.
Oh, yeah, we just come on up here.
Seriously, again?
Yeah, let's check.
296.
296.
Man, I'm good at this.
Keep doing it.
Yeah, right. 416. All right. 416. Second. All right. 213. All right. Third time's a charm.
All right, so what do we have next? Okay, one more book. Eric?
376.
376. Yeah, it's like, oh!
261.
261? It sounded like somebody had that ticket. No? No? All right. 261.
393.
393. Good. All right. Yeah.
426.
426. Ah, is that? Oh. It's like.
Right, who wants it?
Yeah, really? Just make up numbers. 226.
Yes. All right. All right. 226. All right. We're going on to a couple of wine prizes from Grant Eddy. 2 bottles of wine.